for Unit 7. We're getting into geometry. The first part of Unit 7, we're just going to be looking at area and circumference of just kind of basic shapes. So let's look at parallelograms first. A parallelogram is a quadrilateral with opposite sides that are parallel and congruent. So we know these opposite sides are parallel and congruent. So I can show that they're congruent with those tick marks and parallel with these little arrows. Steps to finding the area of a parallelogram: we identify the perpendicular height and the base connected to that height at a right angle. Use the formula area equals base times height, and remember that units are always squared. So I always look for the height first. I see this dotted line, I see this 90-degree symbol, and it matches up with this side length. So to find my area, I am plugging in 18 times 7, which equals 126 feet squared. This 9 is extra information. I always think about if you're at the doctor and they asked you for your height, you're not going to slant. You're going to stand straight up perpendicular. All right, number 2, I find my perpendicular height here. I find this little 90-degree symbol, which shows me it's connecting to this side at the 90-degree angle. So to find my area, I'm doing my base of 11 times my height of 8.7, which is 95.7 centimeters squared. So that was just a quick review for parallelograms. Now let's look at triangles. So basically the same thing. We're identifying that perpendicular height and base, but we're using the formula area equals base times height divided by 2, or you can use the fraction 1/2 times base times height. Again, I always like to find the perpendicular height first. I think that's easiest. I see this 90-degree symbol and dotted line. It's connected to this side. So that 6 is actually extra information there. So to find our area, we're doing our base of 2.3 times our height of 5.44 divided by 2. So 2.3 times 5.44 is 12.512 divided by 2. And I get 6.256 centimeters squared. If you rounded to the nearest tenth, that's fine too. All right, number 4, I'm looking for that perpendicular height. I see that 90-degree symbol. It's connecting this height to this base. So that 12.3 is extra information. So I am doing my base of 3 times my height of 10.5 divided by 2. 3 times 10.5 is 31.5 divided by 2. And I get an area of 15.75 millimeters squared. All right, so that was a quick review of parallelograms and triangles. Let's look at trapezoids. So a trapezoid is a quadrilateral, so it has 4 sides, but it only has 1 pair of parallel sides. So in this case, all that we have is 1 set of parallel sides. The other 2 sides would eventually intersect. And then it still has a perpendicular height that connects those 2 parallel sides. So those 2 parallel sides are our bases. And then our formula, the one we're going to use most often, is just base 1 plus base 2 times the height divided by 2. You can use this one if you've got fractions. So we're basically kind of averaging out these bases. Because one's too short, one's too long, we're kind of finding what's that middle value by adding those bases and dividing by 2. So let's look at number 5. I see my perpendicular height. I see the 2 parallel sides that that's connected to. So plugging into my formula, I'm doing base 1 of 18 plus base 2 of 12 times our perpendicular height of 11 all over 2. 18 plus 12 is 30 times our height of 11 divided by 2. 30 times 11 is 330 divided by 2 equals 165 yards squared. All right, number 6, same idea. This time our parallel sides are on the right and left because I see my perpendicular height horizontally here. It is attached to these vertical parallel lines on the left and right side. So finding our area, I'm doing base 1 of 46 plus base 2 of 12 times our height of 27 divided by 2. Again, these sides are extra information. 46 plus 12 is 58 times our height of 27 divided by 2. 58 times 27 is 1566 divided by 2 gives us 783 meters squared. So those were our polygons, parallelograms, triangles, trapezoids. Now let's look at circles. So circles, some key terms that we need to know. A diameter is the distance what is that saying? The distance through the circle and its center. So specifically, it's going across, actually that should say across. Across the circle through, that's what I meant to say. Distance across the circle through its center. So it goes from one end to the other, but it has to go through that center point. The radius is the distance from the center to any point on the circle, so halfway across. For the circumference, there's 2 formulas that you can use. So the circumference is that distance around the circle. Basically, it's like the perimeter of a circle. So you can use the formula that circumference equals pi times its diameter, or knowing that a diameter is twice its radius, you could also use circumference equals twice times pi times the radius. So I just use either one depending on what value is given to me. And then area, you only can use radius. So area equals pi r squared. So pi times the radius squared. So if you're given the if you're given the diameter, you can do the circumference formula, but for the area formula, you have to then find the radius before moving on. All right. So first example, we are given the radius. So I'm going to use the formula that circumference equals pi times 2 pi r. So I'm plugging in 2 times pi, we're going to use 3.14 times our radius of 4.5. And I'm just plugging that in. 2 times 3.14 times 4.5, and I get 28.26. Since it's like perimeter, it's just inches, not inches squared. For area, we need the radius. We're given the radius, so I'm just plugging in area equals pi r squared. So area equals 3.14 times our radius of 4.5 squared. So 4.5 times 4.5 times 3.14, area equals 63.585. And if you rounded that to 63.6, that is fine. Now let's try it the other way if we are given the diameter. So for circumference, if I'm giving the diameter, I'm going to use circumference equals pi times diameter. So our circumference equals 3.14 times the diameter of 6.2. Plugging that into my calculator, I get 19.468. If you just rounded to 19.5, that is fine. Area, again, we need our radius because area equals pi r squared. So if that's our diameter, our radius is half of that. So 6.2 divided by 2 is 3.1. So I'm plugging in area equals pi, 3.14, times our radius of 3.1 squared. So I'm going to do 3.1 times 3.1 times 3.14, and I get an area. It's a long one, so I'm going to round to about, so I'm going to do the squiggly line to show I'm rounding to about 30.2 millimeters squared.